Hello, it's Keith here, and this is lesson 65 of the platform-specific series of my Z80 programming tutorials. We're on the Sam Coupe this week, and we're going to be looking at the mouse. So we're going to be learning how to read in from the mouse, and to be honest, this was a bit of a difficult one for me. There's a very good Sam document that I tend to use for my reference. I believe it's an official document, and the document didn't help me at all this time. It really explained something about the mouse, but it didn't seem to make any sense or work. So what I've ended up doing is pretty much reverse engineering it, basically trial and error effectively, to work out how to read in some values, and they seem to work at least on the emulators, because I don't own a real Sam Coupe because they're expensive and I have no room left for more computers because I have an awful lot of them. So what I'm basically saying is this seems to work for me. If I find any advice that tells me I'm doing it wrong, I will change the example code on the website to match, but we're going to be looking at what seems to work for me today, and we're going to discuss how it works. Now, the coding for today was for a future project which I'm currently working on. Hopefully it'll be finished next week. I'm writing a little game. It's called Suck Hunt. It's a kind of Duck Hunt Operation Wolf parody, and it's a stereoscopic rail shooter. By stereoscopic I mean wear 3D glasses. So it needs mouse control for the firing mechanism, and so this was the starting point for me porting the game to the Sam Coupe. Sam Coupe is a fantastic system for this game because it needs 16 colours for the stereoscopic effect. So yeah, this was me writing the basis for that game, and we're going to be looking at the code today. So let's go over to the code and let's take a look. Okay, so I have two examples we're going to look at today. The first is known as Sam Mouse, and this is the raw input coming straight out of the port that we read in from. And the second one is Sam Mouse Cursor, which is a graphical display showing a little cursor and the reading of drags and clicks, and this is what's eventually going to become this Suck Hunt game. Okay, so let's start up. I'm going to fire up the code and we're going to see what it's doing, and then I'm going to discuss how I'm reading in. And as I say, all I can say at this stage is it seems to work. I can't say this is definitely the right way of doing things because I don't, as I say, the documentation didn't really make any sense to me, and it's not really what I'm ending up doing. Okay, so what this example is doing is it's reading the X and Y axis into D in HL, and it's reading the mouse buttons into AF here. So if I just capture the mouse here, and then I'm going to drag my mouse to the right here, and you can see the DE value is going up, and the more I drag it, the higher the value is going. And if I drag it to the left, it's negative. If I drag up, then the values are positive, and if I drag down in HL, that is, and if I drag down, the values are negative in HL. If I press the left mouse button here, you can see AF has gone to 5E. If I press middle, 5D, right, 5B, and of course we can press multiple at the same time. So that's the reading we're doing. We're reading in both axes and the buttons, and all of this is done almost with the keyboard port. We have to we have to define BC as FFFE here. The top B byte needs to be double F here for this to work. Now, what we're doing then is we are reading in repeatedly from this port, and it seems we effectively have to strobe the port to get the signal. What we're doing then is we're reading in 3 times from that port, and we're ignoring the first 2 values, and the third value is actually the mouse buttons. And the mouse buttons will basically be that the lowest bit is the left mouse, the next bit 1 will be the middle mouse, and the bit 2 will be the right mouse buttons. And then we read in another 3 times, and we get 3 nibbles. The low 4 bits are one of the nibbles, and the first nibble will be the high nibble, the next nibble will be the mid nibble, and the third nibble will be the low nibble, and the first read will be the y-axis, and the second read will be the x-axis. Now, I did notice something quite interesting. If we don't complete the read, if I just disable the second axis read, well, now you'll notice that rather than giving a difference between the last read and the current read, we're now getting a constant value which represents the current mouse cursor position. So it seems that not completing this read procedure is actually not resetting the mouse. So rather than giving it a movement value, it's giving now a position, because I guess the mouse is remembering the last complete values it gave and zeroing its setting after those complete values have been set, and then giving the difference on the next complete read. And I've put a very large delay in here just to see if the mouse is actually remembering the difference over a period of time, or whether it's giving a relatively immediate value, and it doesn't seem to be. It seems to be basically storing an update and then passing that update to the system when the full read is done by these commands here, and then resetting its internal value and remembering the next update for when it's asked for it next. So I thought that was quite interesting. So here is the code that I'm using. You can see we're using this do axis here, 3 reads here. I'm clearing off the top bits, just keeping the bottom 4 bits, and then we're just shifting the mid nibble here and we're storing them in DE here. That's the y-axis here, then we're flipping DE and HL and doing again for x-axis here. Of course the fire buttons, the mouse buttons, sorry, those are read in here and just pushed into AF here. So basically the reads as I understand them are represented by this table here. So we repeatedly read in from port FFFE, we ignore bits 4 to 7 in all cases, and we read in these bits here, and we get left, center and right here, and we get Y and X, high, mid and low nibbles, which will make up a 12-bit movement value for X and Y. At least it seemed to work in my testing, so that's what I have done. Okay, so that's what we've done here, and this is the basic value version, which just gives screen values. This is the more advanced graphical version, which is the, as I say, the sort of template for my little game. So here you can see we've got a mouse cursor here, and we can now move that around, and it's limited to the screen, which is what we will want for a game. And if I press the left fire button here, you can see we've drawn a Chibico. That's the mascot for this website. And if I draw 2 in the same position, you'll see it actually disappears, and that's because these are XOR sprites. XOR is where we flip the bits based on our image, and that means if you draw twice, it disappears. So it's a quite simple, effective way of making a little graphics routine. If you need to remove a sprite, you don't need to redraw the background, you just draw the same sprite in the same position twice. And that's what I've done here, because that's what my Suck Hunt game does, because it needs to apply 2 separate layers for the stereoscopic effect. One is in cyan and one's in red, and the colours where that overlaps become white. So that's what I've done. So the clicks will draw the Chibico character, and a click and a drag will draw a trail of blobs, and they're XOR again, so you can see they're inverting themselves in some cases. The right mouse isn't used in this example. And we're just going to very quickly go over the code that has made this example, just as I say, as a bit of a bonus, because it's a nice practical display of how we can use it. Okay, so we've got this read mouse function here, which reads in from the mouse, and you can see we've basically got the same code as before. We're reading in here, getting the joystick buttons here, reading in the axes here, and then we're testing the left mouse button here. If the left mouse button is pressed, we're going to see if the fire button is currently held. If the fire button isn't held, then it's been pressed for the first time, and we're setting the fire held flag in that case, and we're turning on fire down. Now if fire is no longer being pressed, we release fire held. Now fire down is not released. The releasing of fire down is done when our processing handles the mouse being pressed down by drawing that Chibico character on the screen. So that's the difference there. That's why that's different. Then what we're doing is we're flipping the y-axis, because the y-axis on the mouse on this system goes up the screen and we want it to go down. Our coordinates go down the screen. So we're just flipping that. And then what we're doing here is we are testing each of the directions and checking if they're going to go off the screen. Now the screen's 128 bytes wide, so we're testing 128 there for our x-axis. We're doing 192 for our y-axis here, and we're also checking the zeros just to see if we've gone off the screen in those directions, gone below 0 basically. So that's our range checking there. And so this is getting a valid position for the cursor. So that's what our mouse move does, and then the rest of the code is relating to handling those mouse movements. So we're checking if the fire button's pressed. If the fire button is pressed, we're going to draw our Chibico sprite using the show sprite routine, which is an XOR sprite routine. Otherwise, it's almost exactly the same as the simple series. And then we're clearing that fire down so that we don't keep drawing Chibicos. We're then updating the mouse cursor. We remove the old cursor. Because the sprite's XOR, we just draw the cursor in the current position, the old position, and that will remove it, and then we load in the new position and show it again using the same sprite routine. As I say, I know people hate XOR sprites because they are ugly. I'm not denying that, but they are fantastically simple if you're looking to create a game with some movement and you don't want to worry about how to redraw your backgrounds and how to cope with one sprite overlapping another and then moving away. It's a pain. So XOR is a nice, easy way of doing things. So there we're drawing our sprite, then we're checking if the fire is held, and if it is, we are showing drag sprites here, and then we're just looping around and doing the whole thing again. So as I say, very simple code here. Here's our show sprite routine. It's almost exactly the same as the old version. The old version we're using the simple series would load in from DE and then write to HL. This version just XORs the current value on the screen with the new value on the screen, and that does the entire job. Very simple. So that's that's all based on the simple series, nothing new there. And the final thing is we've got some variables here for storing our coordinates. I'm using 16-bit values, and that's because on the Amstrad CPC I needed to work in half values in some cases for smooth movement. We're using just the top byte for the actual screen per coordinates, but we've got a sort of fractional value there. That's why we're using words rather than bytes. And then we've got our sprites here for the cursor. You can see the 3s make up the crosshair there, and the drag icon, and then the Chibico is being imported. That's all there is to it. So as I say, I was worried I wasn't going to be able to get the mouse working, to be honest, on the Sam Coupe, because I really couldn't get any sense out of the documentation, which was a surprise, because that documentation's always been fantastic in the past. But hopefully, it seems like I've been lucky enough to manage to get it working. I say hopefully, because I'm not entirely sure I'm doing it right. All I can say is it seems to work well enough for my purposes. So there we go. So that's all we're going to be covering today. If you've liked today's video, please hit the like button. If you like the videos, then YouTube recommends them to more people. Also, if you subscribe, then you'll see when the more Sam Coupe videos come out, because that Suck Hunt game will be coming shortly, and there'll be other videos coming along as well. Anyway, if you want, you can go to my website, download the source code for today's example, and if you can make any use of it, then please go ahead. Thanks for watching today, and goodbye.